Hello everyone. The purpose of this video is to show you how you should analyze your data that we collected in lab and then how we will use Mathematica to fit the data. So I have Jessica's data here because she agreed to be our guinea pig. So she would have entered her enzyme stock concentration, and this is from the BCA assay, and then she would have calculated the enzyme molecular weight in grams per mole. So the next thing that you have to do then is you need to calculate the concentration of your enzyme. So if you do milligrams per milliliter, that's the same thing as grams per liter. And then if you divide by grams per mole, you will get the enzyme stock concentration in molarity. And then sometimes it's nice to be able to convert it to micromolar. So we'll just take this value and multiply that by 10 to the 6th power. So let's decrease some of those. That looks good. Okay, so that's the enzyme stock concentration in micromolar. Some of us diluted our concentrations, but Jessica says that she did not do that. So it turns out that her working solution was the same concentration. So if you diluted, say, 1 to 5 or 1 to 10, you'd account for the dilution factor. 10 microliters is used in the assay. The total assay volume is 3,000 microliters. So in order to calculate the concentration of the enzyme used in the assay, you would do a V1M1 equals V2M2 calculation. So if you had 10 microliters of a 14.4 micromolar solution divided by 3,000, that would give you your assay concentration in micromolar. But if we're going to convert it to nanomolar, let's multiply that by 1,000, and let's adjust those sig figs, and that will be the concentration of enzyme in the assay in nanomolar. It looks like I kept this right here. So the OAA stock concentration, I weighed out 315 milligrams and dissolved it in 53 milliliters. Sometimes it's easier to adjust the volume than to adjust the mass. That's the OAA concentration. And here you can see that what I did is I used the mass and the volume to calculate milligrams per milliliter, and then the molar mass to calculate the concentration of the OAA stock solution molarity. And here I just multiplied by 1,000 to have the concentration in millimolar, and then I took that concentration of the solution and I diluted it 1 to 10. So if you look over here, these are the volumes that we pipetted. So first we used the 4.5 micromolar solution. So I'm going to put I want to copy this. I'm going to do $B, $25, and then I'm going to copy that here. And then we use the 45 millimolar solution. So I want to copy that. So I'm going to do $B, $22, and copy that. And then I need to know the concentration in the assay. So once again, V1M1 equals V2M2. So we will have used 3.2 microliters of a 4.5 millimolar solution, and the final volume of the assay solution would have been 3,000 microliters. I'm going to want to copy this, so I'm going to put $signs here, and I want this in micromolar, so I'm going to have to multiply this by 1,000 because I had my concentration in millimolar. Okay, so now I can copy this all the way down, and those are my concentrations of OAA in the assay. So these are the absorbance units per second that Jessica and Catherine would have calculated. So I did type in these values, and for we want to calculate the average, so we have an average right here. The next thing we want to do is we want to convert this to velocity, but we want to use the uh, units of micromolar per second. So we're going to use Beer's law. We have the epsilon value right here. So what we're going to do is we're going to multiply by -1. And it is because we're going to define the velocity as the disappearance of NADH. So I'm going to multiply by -1, and then I'm going to take this value because in order to calculate the concentration, we'll take the absorbance divided by the extinction coefficient, and the path length is equal to 1. Okay, so that gives us our velocity in micromolar per second. And I'm going to copy this too, so that's going to be L7. So let me put $L, $7, and then go ahead and copy and paste that. Okay, so those are my velocity values. And then I want to do the same thing here. Let's see if that works. No, it doesn't. Okay, so let me do the same thing where I multiply by -1, and then I'm going to take the absorbance from the second trial, again divided by the extinction coefficient. Okay, that looks much better. And let me again use the $L, $7, and now I can copy all of these values. And I want the average, so let's do the average of trial 1 and trial 2. So, and then copy and paste, and then we can convert this to nanomolar. So let's take the velocity in micromolar and divide by 1,000. Oh, no, sorry, multiply by 1,000. No, divide by 1,000. No, multiply by 1,000. Sorry, it's late. Okay, so velocity first trial, that's in micromolar. Yes, multiply by 1,000. So let's copy that and paste that. And over here, we'll do the same thing. That's for trial 2, multiply by 1,000, and copy and paste. And then let's do an average. And the average of each trial, copy and paste. Okay, good. Okay, so now I want to calculate the K observed, and that's velocity over enzyme concentration, and we want velocity and enzyme concentration to have the same concentration units while everything is in nanomolar. So the K observed is velocity, which is this, divided by the enzyme concentration in the assay. So I have to go way back here, and there is, where is it? There it is, the concentration of the enzyme in the assay. So again, if I want to copy these, let's do $B, $16, copy and paste. So I get the K observed for trial 1. And let's do it again for trial 2. So that's going to be trial 2 is the velocity, again, divided by the enzyme concentration in the assay, which is over here. So let's do $B, $16, and copy and paste. And then average these two. And now I have my averages. Okay, so I have a full data set. To use Mathematica, we are going to plot the averages, but we're going to fit the averages, but we're going to plot both data. So what I want is I want the concentrations of OAA, so in the assay, which is here. So I'm going to copy this. So I'm going to hit copy, but when I paste it, I don't want any formulas. So when I go over here, when I go to paste, I'm going to paste where it says 1, 2, 3, and then it's, if you look over here, it just pastes the number. It doesn't paste any of the formulas. So I'm going to do the same thing with the K observed, and here I'm going to use the average. So sorry about that. I'm going to copy the average. So let's copy that and then again paste just using the numbers. So then I have a little line right down here. So I could actually just copy this right here. So let's do copy and paste for trial 1, and then I can, I think apply, would I be able to paste again? Let's see. Yeah, that works. I've pasted these both ways, and now I want the velocity in nanomolar per second for trial 1. So again, I'm going to copy, and then when I paste, I'm just going to paste the numbers, and then for trial 2, again, I'm going to copy, and then I'm just going to paste the numbers. Okay, so I'm going to compare this with what I did before when I was not on camera, and it looks like something is a little funny. Okay, so let me fix this. Okay, so we want K observed. Oh, I think I might have done velocity. Oh, I did velocity when I'm supposed to do K observed. Okay, so let's try again. K observed, that's trial 1. Let's do copy and then paste and then just do the numbers. Okay, that looks a lot better. And then here's K2, copy and then paste and again just do the numbers. Okay, that looks much better. So what I'm going to do now is I'm going to start a brand new workbook, and I'm going to go back to the numbers that I crunched over here, and I'm going to copy just the numbers with the blank space, no heading. So I'm going to copy this. So let's do copy, and then I'm going to go back to my workbook, and then again just paste the numbers. And what I'm going to do now is I'm going to save this as so let me go back and put this on my G drive so we can see it in class. So let's put this in my Mathematica folder. Okay, so this is I've already done this before, but let me do this for my recording. And I'm going to save this as a CSV file. So I gave it a name, and I'm going to save it as a CSV file. So now I'm going to save it. So I'm going to close this now. And I'm going to close, I think I'm going to go close both of these. Yes, I'm going to save this. So what I'm going to do now is now I'm in Mathematica. So what I want to do is, this is the template that we gave you. So, and it has data that I used for the wild type enzyme a year ago. So what we want to do is we want to use this as a template and then just copy over it. So the first thing is to import the data, find the correct path. So use the Insert tab and then File Path. And then I'm going to go to the G drive and I want the CSV file. Where is it? Oh, it's here. Okay, so there's my CSV file, and I'm going to choose that. So now I have my, so find the file that you want to import, and then it's supposed to be here somewhere. Oh, it's up here. It's really tiny. Okay, so it's up here. So that's my file. And then the next thing I want to do is I want to import this. So what I'm going to do is I'm going to copy this entire line right here. I'm going to copy it, and then I'm going to replace our the template that we gave you, and then I'm going to hit paste. So now it says to import these data right here. So it says then you import the data, so everything is formatted, and then you have to hit Shift Enter to send the command. Hopefully I can do this right. So Shift Enter. So yes, that worked. So what that did is that replaced the data in the my old data with Jessica's data. Okay, so far so good. So now we want to copy and paste the data and define the data sets because we have our average data and our full data. So if I look up here, that's my average data, and there's that then there's this separation between the average data. It just has the curly brackets with the little comma there. So I believe that if I copy this with just in the curly brackets and put it in here so that I have double okay, not, let's see, um, double curly brackets and then hit paste, that should work. And then I want to take the average data in between the curly brackets and hit copy. And this is the full data set. So this is all of my trials, and I'm doing this in between the curly brackets, and I'm hitting paste. So now what I want to do is I want to define this data set, but it's not wild type anymore. I'm just going to put JW, and then how about, no, it doesn't like that. Okay, JW, I'll just do JWMT for JW and mutant. And then I'll do the same thing over here. JWMT for mutant, and I put the OAA right there. Okay, so now what I should do is I should, if I hit Shift Enter, that should define the data set. Yes, and you see that it goes from blue to black, so now I've defined the data set. So, okay, so I think this looks okay. So now I want to define the nonlinear equations. We're going to use the modified Michaelis-Menten equation that we used in class, and I believe if I let's see, just to make sure I got this right, I'm going to put my cursor right here and do Shift Enter. Okay, so far so good. So I've defined my Michaelis-Menten, but now I want to make sure that it fits, it does a nonlinear fit on the right data. So if I just do this, all right, I think if I just start typing JW, yes, it'll just, it knows that it's JW, the average data, and I just do that. And if I do the same thing over here and I just start typing a J, oh, that doesn't look like it worked. JW, okay, there it is. There's the full data. Okay, so now I have the average data and the full data. So I believe now that if I just put Shift Enter in this box, it should do the nonlinear fit, and it's supposed to give me a little box with all of my data. It doesn't look like it did that. It said it's not a list or a rectangular array. Okay, so I will, oh, maybe it was because of this right here. That's average data. Let me do that. And this is supposed to be the average data. Okay, so let me try again. Shift Enter. Okay. I'm going to stop the recording and see if I can figure this out.